Okay, great. So our first question is asking, what are all the angles equal in measure to angle 1? And you can kind of tell from the diagram here which ones are bigger because angle 1 is right here. And it's obviously much bigger than angle 2, which is here. And you'll notice that angle 1 and 2 add up to 180 degrees because they're on the same line. So if we look for all the big angles, angle 3 here is also a big angle. Angle 5 is also a big angle. And angle 7 is also a big angle. So the thing you have to remember here is that whenever you have two lines crossing like this, opposite angles are always equal. So angle 1 and angle 3 are equal, and angle 4 and angle 2 are always equal. And we have a similar thing here. Angle 5 and angle 7 are equal, and angle 6 and angle 8 are equal. Now, in terms of lines, since these two lines, lines K and line I think that is parallel, you have to always remember that this angle, angle 1, and this angle, angle 5, are always equal. So corresponding angles will always be equal. 1 and 5 are equal, 2 and 6 are equal, 4 and 8 are equal, and 3 and 7 are equal. And keep in mind, this only works if these two lines are parallel, and then there's a line crossing through them, and that line is called the transversal. Okay, so we're going to go over some basic definitions here. And I'm not sure what geometry background you guys have, but we're going to start with the most basic question here. What is an angle? So an angle is basically any degree measure. So for example, if I draw a circle here, a degree is defined as 1 over 360 of this circle. So 360 degrees, and that's the notation for degrees, is equal to 1 revolution around the circle. And then you can cut that revolution into fractions. So let's say if you wanted just half the circle, this angle here would be half of 360, which is 180 degrees. And if you cut that in half again, this angle here is 90. And typically when you're talking about 90-degree angles, you can always label them with a little square, like I did right there. So that would be 1/2 of 180 degrees is 90 degrees. So that's what an angle is. And now we're going to learn about the definition of complements versus supplements. So a complement of an angle, let's say x, is another angle such that x and that angle, let's say y, add up to 90 degrees. For example, if I gave you the angle 30 degrees and I asked you what is the complement of 30, you would give me 60 degrees because 90 minus 30 equals 60. Similarly, a supplement is when two angles add up to 180 degrees. So if I gave you x, then x plus y would equal 180 degrees. For example, if I said, what is the supplement of 45 degrees? Then you would give me 135 because 180 minus 45 is equal to 135 degrees. So sometimes problems will use the word complement and supplement, and so that's what those mean. Someone just asked if there's a trick for remembering this. As far as I know, there is no easy trick because it's basically terminology. So you just have to remember the word complement and 90 degrees and the word supplement and 180 degrees. Okay, so next we're going to go over the sum of the angles in the polygon. And let's draw some examples here. So the polygon with the least number of sides, you probably already know, is a triangle. And a triangle has 3 sides, which means it also has 3 angles. 1, 2, and 3. So the 3 angles of a triangle add up to 180 degrees. And so let's also take, for example, a quadrilateral, which is a polygon with 4 sides. The angles in the quadrilateral add up to 360 degrees. And a simple way you could convince yourself that this is true is that if you take the most basic quadrilateral, which is a square, there are 4 corners of a square and each one is a right angle. So 4 times 90 degrees is 360 degrees. Now there is a formula for the angle for the sum of the angles of any polygon given its side lengths. And that formula is 180 times n minus 2, where n is the number of side lengths. And you can see that this is true, like for example, a triangle, n equals 3. And if you plugged in 3 into this formula, 180 times 3 minus 2 is equal to 180. And for a square or a quadrilateral, n equals 4. And when you plug it in, 180 times 4 minus 2 is 360. So this right here is a very important formula. You guys probably want to memorize this. It tells you the sum of all the angles in the polygon. And if the question tells you that the polygon is regular, meaning, or at least equal angular, meaning that all the angles are the same, then each of the angles on the polygon is just 180 times n minus 2 divided by n. So that's useful in a lot of problems. And finally, here in basic definitions, we're going to cover exterior angles. So the basic definition of an exterior angle is an angle on the outside of a polygon. So for example, if I told you, if I gave you this triangle, and I said that this angle right here is 60 degrees, this angle right here is also 60 degrees, then what is this angle? Which I'll double angle here. And most of you guys are saying 120 degrees, which is correct. And there are several ways you could figure this out. You can note that this down here is a line, which means all the angles on it add up to 180 degrees. And because this triangle is equilateral, and because its angles add up to 180 degrees, then 180 minus 60 minus 60 is equal to 60 degrees. Meaning this angle here is also 60 degrees, and 180 minus 60 degrees is 120 degrees. So that is what an exterior angle is. And obviously a shorthand for this is if I gave you any triangle and I asked you what is the exterior angle, this angle is always the sum of the opposite two angles in the triangle, which is the exterior angle theorem. So let me use some different colors here. The outside blue angle is always going to be equal to the sum of the two red angles. And that's useful to remember. And also keep in mind that there can be exterior angles for stuff that aren't triangles too. So for example, if I drew you a pentagon, this right here would also be called an exterior angle. So it looks like that covers basic definitions. Does anyone have any questions? Okay, the first response I got was no, so we're going to move on. So the way I arrange these problems is that it's going to start out very easy, and then it's going to get challenging. So we have a challenge problem section at the end of this. So here's our first question. If the supplement of angle x is 5 times the complement of angle x, how many degrees are in the measure of angle x? So keep in mind that you have to remember the definition of supplement and complement. Don't forget that supplement is when the angles add up to 180, and complement is when they add up to 90. Okay, so let's start. So they give us an angle x. They give us an angle x here. And they're talking about the supplement of angle x, which by our definition we know is 180 minus x. And they're also saying is, which means equals. So this is equal to 5 times the complement of angle x, which we defined as 90 minus x. And they're asking us to solve for x. So basically, we can reduce this into an algebraic equation. And you can solve here. You can do 180 minus x is equal to 450 minus 5x, or 4x is equal to 450 minus 180. And when you solve this equation, you should get 67.5 degrees. Okay, so let's move on to the next problem. Okay, lines TP, BG, and DM intersect at point O. The measure of angle BOT is 47 degrees. The measure of angle MOG is 29 degrees. How many degrees are in the measure of angle DOP? Okay, so hopefully you guys had some time to think about that problem. So they're saying that the measure of angle BOT is 47. So BOT, this measure here is 47 degrees. They're also saying that MOG is 29 degrees. There's MOG, 29 degrees. And they're asking us for DOP, which is here. So it's a good idea to always label what they're asking you. So we notice that BG here lies on one line, which means that this angle here, TOM, is equal to 180 minus 47 minus 29. And that should come out to 104 degrees. But don't forget that what we learned from the warm-up problem is that if we have a line here and a line here, opposite angles are always going to be equal. So TOM is equal to DOP, which means the measure of DOP is 104 degrees. Okay, let's move on to the next problem. In the figure below, regular pentagon AGHIF sits inside regular hexagon ABCDEF, so that the two shapes share base AF. How many degrees are in the measure of angle GAB? Keep in mind for this problem that we have to remember what we learned before, that the sum of all the angles in a polygon is 180 times n minus 2. Okay, we have a few people who got the answer, so let's just go ahead and start. So they said that the pentagon and the hexagon both are regular. So since all the angles are equal, we know that for each one, we can do the sum of the angles divided by the number of sides to get each specific angle. So since they're asking us for GAB, we can get GAB by doing BAF minus GAF. So BAF is one of the angles in the hexagon. So therefore, its measure is equal to 180 times n is 6 now, so 6 minus 2 divided by 6, which is equal to 30 times 4, which is 120 degrees. And GAF is an angle in the regular pentagon. So here n is equal to 5. Which is equal to 108 degrees. And so therefore GAB is the difference of the two, which is 120 minus 108 equals 12 degrees. And so that should be our answer. Okay, let's go onward. So in the figure below, angles GRM and MRT are complementary. The measure of angle TRY is 127 degrees. Find the measure of angle GRY. Okay, let's go ahead and start this problem. So a few people have answers. So they say that angles GRM and MRT are complementary. So if you remember complementary, that means that this angle and this angle add up to 90 degrees, which means this whole thing, you can put a square here, is 90 degrees. And so an entire circle is 360 degrees, which means that the remaining angle is 360 minus 90 equals 270 degrees, which means that GRY plus TRY is equal to 270 degrees. And what do you know? They give TRY as 127 degrees, which means that GRY is equal to 270 minus 127. And that should give you 143. Okay, so if nobody has questions there, let's move on. Okay, in the figure shown below, angles CAE, GFE, and CDB are right angles. An angle ACE measures 27 degrees. How many degrees are in the measure of angle DGF? Okay, so a few people have gotten an answer, so let's go ahead and start. So all the right angles they gave us, they labeled in the picture with the box. They tell us that ACE, which is this angle, is 27 degrees. So that means that angle CBD is equal to 180, because that is the total sum of the angles in the triangle, minus 90, minus 27, which are the two other angles. And that should give you 63 degrees. So we know that CBD here is 63 degrees. So there are a couple ways you can do this problem. I'm actually going to go through a few ways because we have time. So here's one of the ways. So we see that we have a quadrilateral here, which means that all four angles add up to 360 degrees, which you should probably memorize. And since two of the angles here are already 90, that means that these two have to add up to 180. And since CBD plus ABD is equal to 180, And ABD plus BGF is also equal to 180. Then we can do a little substitution here since both of these equations have ABD. And we can find that BGF is equal to 63 degrees. And since they're asking for DGF, which occupies the same line as BGF, then DGF is equal to 180 minus 63, which should come out to 117. So that's one way you can do the problem. Another way you can do it, which is arguably a faster way, is you notice that this angle is 27 degrees. And if you look at the entire triangle ACE, then you'll find that angle AEC is 180 minus the two other angles, which are 90 and 27. So this will also give you 63 degrees. So we know this angle here is 63 degrees. And now we can look at this quadrilateral, whose angles add up to 360 degrees. And since we have a right angle here and a right angle here, that means that FGD plus FED is equal to 180 degrees. And FED is the same thing as AEC. So we can plug in 63 degrees here. And we'll also get FGD is equal to 180 minus 63 is equal to 117. So both ways will give you the same answer. Does anybody have any questions? Okay, so let's move on. Let's see here. I am not sure when I started this meeting, so because there's a 40-minute time limit. Oh, cool, it tells me how much time is on here. Oh, we still have some time. So let's just do this problem too. The measures of the angles in the diagram to the right are as marked or below. Find angle C. Oh, keep in mind, guys, they want you to find angle C as an actual number, not just in terms of X. So if you found it in terms of X, then you're probably not using some piece of information that they gave you. This one's a little bit harder, so I'll give some extra time. So for those of you who can't find the actual value of c, but already found that c is equal to x, remember that you have AC and AB are parallel. And you probably have not used that yet. So think back to the warm-up where we found all those angles that were equal. Okay, so let's go ahead and get started. So the first thing that I saw many of you do, or you probably did, is that you use the exterior angle theorem. And so from the exterior angle theorem, you know that angle CBD is equal to the sum of the other two angles in the triangle ABC, which is CAB plus ACB. Since they gave you that CAB here is 3x, and they gave you that CBD is 4x, that means that ACB is x. So this angle here is x. So you found angle C in terms of x, so now we have to try to find it in terms of an actual number. So you'll notice that this line here and this line here are parallel, and you still haven't used the information that this angle is 2x. So let's try to use those two pieces of information here. You'll notice that if you remember back to the warm-up, then you know that angle ACB plus CBE is equal to 180 degrees. And we know that since, if you remember from the warm-up, you can extend line CB here. And so this angle here will be x, because since these two are parallel, the angles in the same positions are equal. And so therefore CBE would be 180 minus x, since they're on the same line. So we have here CBE is equal to 180 minus x. So now we notice that these angles here are all in a circle, which means they add up to 360 degrees. So you can get that 4x plus 2x plus CBE, which we found is 180 minus x, is equal to 360 degrees. So you get 5x equals 180, or x equals 36 degrees. And since x was the original value of angle C, then we found angle C. So does anyone have any questions for that? Okay, so we're running out of time here, and we're going to save the challenge problems for next time. So keep in mind that these problems are going to be much harder than what we already did. And if we have time, we'll go on to the next unit next time too. So before the meeting ends, I just want to remind you guys, let me click past these. Wow, you guys know the answers already. Okay, so Check out our website at alphastemlearning.weebly.com. And also, please be on the lookout on Google Classroom for a form that I'm going to post later, so you guys can let us know what kind of stuff you want on the website. And also, don't forget, guys, that Benjamin has a Q&A session after this until 7 o'clock. So if you have any questions about anything you've seen in this class or outside of this class, then head on over to Benjamin's Q&A session, and the information is posted in Classroom. So I hope you had fun, guys, and I'll see you next time.